Morning, children. This video is all about solving exponential and logarithmic equations. For example, if I wanted to solve for x in the equation 5 to the x power equals 15, I would need to rewrite this as a logarithm. I would have to say log base 5 of 15 equals x. And then that's something I could punch into the calculator or use the change of base formula and get x equals 1.683. I do want 3 decimal places. So if I wanted e to the x equals 12 and I wanted to solve for x, I would have to take log base e, which is ln, of 12 equals x. Then I can do the natural log of 12 in the calculator and get 2.485. They might get a little harder. Throw in a little plus 3, 10 to the 2x plus 3 equals 8. So first I have to take away 3, get the exponential part all by itself, and then we can rewrite it as a log. Log base 10 of 5 equals 2x. And then we can punch in log 5 in the calculator, divide it by 2, x equals 0.349. So as you can see, solving these, you just have to work PEMDAS backwards until you isolate your exponential function. So here we need to take away 8. It's an e to the negative x equals negative 1. Then I need to divide off the negative 12. That has to go away too. So e to the negative x equals negative 1 divided by negative 12 would be 1/12. Then I can take the logarithm, in this case the natural log of 1/12 equals the exponent negative x. So I take the natural log of 1/12 and I negate it, and I will get x equals 2.485. Make sure you isolate your exponential. In this case, e to the negative x needs to be isolated before you can do the logarithm. So now I'm still trying to solve for x, but now instead of having an exponential, I have a logarithmic function. Log base 10 of 2x equals 1.5. So if the x you're looking for is inside of a logarithmic function, rewrite it as an exponential function. Our base is 10. We're going to raise it to the 1.5 power, and that will equal the 2x, the whole 2x. So now I just take 10 to the 1.5 power, divide it by 2, and then I can get x equals 15.811. Or if we have a natural log of x equals 4, and I want to know what x is. I've got the logarithmic function isolated, so I take the base e, raise it to the 4th power, equals x. E to the 4th can be punched into the calculator, so x equals 54.598. We're always going to go with 3 decimal places. So here's a messier one. Remember, you have to isolate the logarithm before you can change it to an exponential. So first I need to subtract 15. 2 log base 2 of x equals 31 minus 15 is 16. And then I need to divide off the 2. Log base 2 of x equals 8. Then I rewrite it as an exponential. 2 to the 8th equals x. And 2 to the 8th is 256. So one more of these. 2 times the natural log of negative x plus 7 equals 14. Some of you guys are looking at that going, you can't take the natural log of a negative number. Well, if x is a negative number, so I'm doing negative number, then I could. So this is possible. We should get a negative number as our answer. And we need to make sure we isolate the logarithm first. So PEMDAS backwards says we're going to take away 7 first. 14 minus 7 is 7. And then we're going to divide by 2. Natural log of negative x equals 3.5 or 7 over 2. Either way you want to say it. So now we've isolated the logarithm, we have to rewrite it as an exponential. E to the 3.5 power equals negative x. So take e to the 3.5 power and negate it, and we get negative 33.5 0.115. So if you plug in a negative to negative x, it becomes positive and it's fine, it works. So here's an uglier one. I've got log base 6 of 3x plus log base 6 of x minus 4 equals 2. And I need to solve for x. So when you see two logarithms or more, just know, okay, well, we learned how to expand and condense, so I need to condense this down into log base 6. Log base 6. There's a plus here, so I know it's going to turn into multiplication of 3x times x minus 4 equals 2. So that's why expanding and condensing is very important. Now I do have the logarithm isolated. So now I'm going to rewrite it. 6 is the base, 2 is the exponent, 3x, x minus 4 is what it equals. And so that's saying 36 equals, and I'm going to distribute the 3x so that I have 3x squared minus 12x. So now I know I've got an x squared. I'm trying to solve a quadratic. Quadratics must be set equal to 0. 3x squared minus 12x minus 36. To solve, you could factor or use the quadratic formula or complete the square or graph. So I'm going to factor this one. First thing I'm going to do is divide everything by 3. And then factor that down. Factors of negative 12 that add to negative 4 are going to be negative 6 and positive 2 equals 0. X equals 6 and negative 2. Now, something that's important to do, and it's important to do every time, I just hadn't mentioned it yet because we were doing really simple ones, is you need to always check your answers. Check your answers, make sure that they work, especially when you're solving a quadratic. So if I checked 6, and remember, when you check, you have to go back to the very beginning, the original problem. Log base 6 of 3 times 6 plus log base 6 of 6 minus 4 should equal 2. Okay, so log base 6 of 18 plus log base 6 of 6 minus 4 is 2 should equal 2. Condense them together, we get log base 6 of 18 times 2 is 36. Should equal 2, and that's true. 6 to the second equals 36, so we're good. Let's try the other one. Log base 6 of 3 times negative 2 plus log base 6 of negative 2 minus 4 equals 2. So I'm taking log base 6 of negative 6 plus log base 6 of negative 6 equals 2. Now, can I take the logarithm of a negative number? And the answer is no. Can't happen. Can't happen. Therefore, the negative 2 is an extraneous solution. It's extra. So the negative 2 doesn't count, and your answer is only 6. So if this was a problem on the test, I'd be looking at your work to see, did you get all the way down to here, get both of these, and then check them. And you can check them in your head or on the paper, but you do have to check them because you have to know that negative 2 is an extraneous solution that does not work. All right, here's another crazy situation. I'm back to exponential, but my variable's in the exponent in two different parts of the problem. So if I used a logarithm, I'd still have it in an exponent. It would just be a big mess. So what you want to do when you have this situation is try your hardest to make them have like bases. So I've got 2 to the x power. 32 is 2 to the 5th power. And then you keep your 3x plus 1. Make sure you put it in parentheses. Once you have like bases, if the bases are alike, then the exponents have to be alike. That's what equals means. So now I can say x equals 5 times 3x plus 1. X equals 15x plus 5. X minus 15x would be negative 14x equals 5. X equals 5 over negative 14. And then we need to just check it and see, can I plug a 5 over negative 14 in for x here and here? And yes, I can, so it works just fine. That's our answer. So here's one. Now what do? How do you make them have like bases when you can't? There's a 3 to the x plus 1 and a 2 to the 3x. So let's do this with a logarithm. We're going to write log base 3 of 2 to the 3x power equals x plus 1. Did you guys all catch that? This is your base here. This is what we're logging, and this is what the answer is. Now, we learned some properties of logarithms that say if I have an exponent right there, I could move it. Move it out to the front. 3x. Log base 3 of 2 equals x plus 1. Well, that's a little better. And if I have something multiplied by something, I could divide both sides by that thing. So now I can have log base 3 of 2 equals x plus 1 over 3x. Getting closer. I've got all my x's on the same side of the equation. I need to solve for x. How can we do that? Okay, let's use a little bit of our math knowledge here. X plus 1 all over 3x is the same thing as x over 3x plus 1 over 3x, which is 1/3, because the x's can cancel, plus 1 over 3x. Alright, I am going to need a little more space. Hold on, I'm going to scroll up. Alright, and that was log base 3 of 2, which is a number. You could go ahead and get it in your calculator now if you wanted to. But equals 1/3 plus 1 over 3x. I'm trying to isolate x. So now I'm going to get that number. I'm going to keep writing log base 3 of 2. Subtract 1/3 equals 1 over 3x. And then I need to cross multiply, don't I, to get x on the right side of the equation. So 3x equals 1 over this number, log base 3 of 2. Remember, that's just a single number minus 1/3. And then I need to divide it all by 3 or multiply it all by 1/3, right? So in the calculator, you're going to divide log base 3 of 2 times 1/3, 1 over that number, and then divide that whole thing by 3. It's kind of a mess, but you get 1.120. So even though it's ugly and hideous and really hard to finagle using your old-fashioned algebra skills, you can do it. You can get x. So that's it. I'll see you guys in class. Have a good night.